Felix is oh, but that's not in D. Okay. Okay. Felix is a software engineer at Tecton, working on Feast. In case you don't know what Feast is, it's a open source feature store. Feature store. Well, Felix recently graduated from Stanford, where he studied math and computer science. He's about to give us a little bit of a coding workshop on, is it ride hailing or is it delivery estimates? What is it? What are we getting a coding workshop on, Felix? Uh-oh. Did I lose you? There he is.
Can you hear me? Real-time credit
back.
Scoring.
It's credit scoring. He's about to give us a coding workshop on credit scoring. And later I'll talk to you all about the ethics of credit scoring and all that fun stuff. But for now, we're just going to learn about the feature engineering and storing and all the values and important stuff. It's great to have you here, Felix. What's up, man? Thank you for joining us. I didn't have enough information there to really give you a fleshed out song, but I hope you enjoyed it. And I'm excited to learn about Feast. I know that many people
Thank you for that
it.
really warm introduction. I have never been serenaded like that before, and it was quite something, I think, to get feature stores in there as well. I'm not sure I've heard anyone be that creative about feature stores, but yeah, this was very, very nice touch.
Yeah, well, this is what you can expect if you come on the MLOps community meetup. So we've got a quorum. There are a nice amount of people, and I think that we are going to just dive right in, right? You've got a lot of stuff set up for us. It is on credit scoring. It is using Feast. I'm going to hand the mic over to you, man. I'll let you do it. And as we mentioned, Felix is going to be walking us through this. Correct me if I'm wrong, Felix. It's on GitHub, so we can all follow along. I wanted to poll the attendees real fast on what the knowledge is of Feast. If anyone has, because Felix and I were talking about this beforehand. I think there's some people that have heard of Feast at least, or some people may have played around with Feast. Maybe we can do this. If you've played around with Feast, can you just let us know in the chat and let us know what you feel like your level of Feast usage is. Otherwise, Felix is going to break down what exactly it does and then go through the workshop. So I'll hand it over to you, Felix. No more singing, no more talking from my end. It's all you, man.
All right. Well, hopefully a little bit of singing later on after we're done, perhaps. But yeah, thanks for the introduction. So as Demetrius said, I'm Felix. I work at Tecton, and in particular, I work on the open source project Feast. And yeah, today I will be doing a Feast deep dive. So I think the level of familiarity I'm going to assume is basically none. So hopefully for folks who may have encountered the project before, I should be able to still teach you a lot. And for the rest of the people who haven't really heard of Feast or haven't really played around with it, I certainly do hope you get to learn a lot throughout this session. It's time to do a tutorial on Feast. So today we've gone over Feast as a project. We've taken a look at some of the documentation, learned about some of the core concepts such as a feature view, feature, and an entity, and now it's time to do a tutorial. So this is public. You should be able to find it on Google just by Googling real-time credit scoring, AWS tutorial Feast, whatever. I'm sure you can find it. So yeah, this tutorial is going to be about building a model to do credit scoring. In particular, this model is going to take in a bunch of features regarding, say, the zip code that you give it and some credit history information, and then it's going to spit out a binary answer, yes or no, on whether or not an individual should be granted a loan. It's also called a real-time credit scoring tutorial because we are interested in running inference on this model. And so really we're going to be doing two things. We're going to be training this model and then using it to run inference. And Feast is going to help with both of these situations. So when training, Feast is going to help you get the training data, and when running inference, Feast is going to help you get your online real-time features. So we're going to take a closer look at how that works. It's also hosted on AWS. So we have a whole bunch of data that's going to be stored. Your historical data for training your model is going to be stored on Redshift, and then your online features are going to be materialized from Redshift into DynamoDB, where they can be retrieved for your actual inference. So I think that's basically everything we need to know before we just dive right into it. So I'm going to pull up the repo. Let's take a look at the contents of the repo. So there's a bunch of Terraform files to set up our infrastructure, in particular all of our AWS stuff, such as the Redshift cluster to host our data. There are some requirements which need to be installed. There's a main run file, which you see here. It basically does exactly what I just said, which is to say it takes a bunch of historical data, creates a model, trains the model using that historical data and pulling in some of the data from Redshift. And finally, it does inference exactly once. So it takes this loan request and then asks the model to predict whether or not the loan should be approved or rejected. This model we can see is over here, and you'll notice that we use Feast in it a couple of times. In particular, when the model is initialized, it also sets up a feature store, and that feature store is what is going to be used when we are getting our training features and when we are running inference. You can see this get online features from Feast. It's going to be calling, yes, feature store.get online features. So we'll be taking a closer look at this code later on. And finally, in here is a feature repo, which is required. This YAML file is required to set up an actual feature store with Feast. So you can see here, we've given it a project name, has a registry, which, as we talked about earlier, I think is where a lot of the feature metadata is stored. Provider, of course, is AWS, DynamoDB, Redshift, and then this other stuff is going to be filled in as we complete this tutorial. So why don't we just get started? So in order to set this up, we are going to need to initialize a bunch of stuff. Okay, we're already in infra. Cool, Terraform has been initialized. Let's run Terraform plan. This plan looks good. I actually realized one issue here is that this bucket name is not globally unique. So we are going to make it globally unique by just adding a bunch of characters to it. Hopefully Terraform plan works here. Great, now let's run Terraform apply to actually set up a bunch of this infrastructure. Yes, and I hope that things are being created properly. Okay, that looks good to me. So we're gonna let that run and take a look at the next step. Okay. So we've set up a bunch of our infrastructure. Once it's deployed, right, we're going to get a bunch of outputs, and I think we're going to, what is this? Create a mapping from Redshift to the external catalog, all right? And then run a bunch of other commands to continue the setup. Okay, that makes perfect sense. All right, so let's wait for this. I think while we're waiting for this, we can take another look at this repo and dive a little bit deeper. In particular, one of the interesting things here is going to be that we have a bunch of data that we should take a look at to understand what we're dealing with. So our loans are going to be coming from this parquet table. These loans are what we are going to be doing training on. This is our training data. But this training data isn't complete. It's also going to be augmented by these credit history and zip code table features. And so let's take a look. These parquet files have the full data sets in them, but these CSV files have a preview. So let's take a look at this credit history sample CSV. And in here, what you can see is a bunch of additional feature data that we're going to be using to augment our training data with. And so the interesting thing here is that each of these columns, or I guess each of these rows, is uniquely identified by this date of birth social security number. Each one of these is kind of the join key that we care about here. And then the rest of these are just your features, credit card due, mortgage due, etc., etc., etc. And so this is a quick sample, the credit history. And then the other one that we care about is zip code table sample. And in here, the join key that we care about is the zip code. So each one of these zip codes will give you a bunch of features like city, state, a bunch of other information, etc. So these are some of the features that are going to be joined on when we do our training. Great, so our infrastructure has been initialized. We now see that there are a bunch of outputs. Do we see that here? We do. So that's good to know. Let's create this mapping. Oops, my bad. The Redshift cluster identifier needs to be copied. Let's do that. And let's copy this again. There. Let's get rid of these quotation marks. Okay, cool. So I'm just going to really quickly copy paste this stuff over here so that nothing, we don't lose it. And what information do we need there? Okay, well, we need to check whether it was successful. And to do that, oh man, what's going on? To do that, we need to put the statement ID in, which is right here. Let's just plug that in. Okay, looks like it was successful. And now we want to check that we can actually query for the zip code statements by doing select star from these zip code features. So let's try this out. And let's again copy our cluster identifier, which we have here. Once again, let me just copy this over here to make sure we don't lose this information. And finally, we're going to check that this statement worked. Great. So it looks like we have set up our infrastructure fine. The data sets do exist on Redshift, and we can actually query for them correctly. So let's go back up and install Feast. So I think I already have Feast installed. Yep. So what's left to do is initialize this feature repo. So as the tutorial says, we've actually already set up this feature repository for you, so you don't need to initialize it, but you do need to configure it properly by setting the appropriate fields in this YAML file. So you'll see here, we need to put the cluster ID and a staging location, as well as an IAM role. So let's go back and find our, where are they? The cluster identifier is right here. down, and then there is the IAM role that we care about. And finally, for a bucket, let's just set up something. Feast. Real-time credit. Let's just do this or something like that. Staging location doesn't really matter, to be honest. It's just where a bunch of data will go. Okay, so this is the YAML file that's been configured for our feature repository. And we should be able to run feast apply now. All right, great. So what happened here is that we configured our feature store with the YAML file to point the offline store to the cluster that we constructed, and using the IAM role that we constructed. A bunch of things here are being registered, as you can see, and there's some infrastructure being deployed. So where are these things coming from? Well, they're coming from, if you look in this feature repository, you can see there's also this features.py file. Let's take a look over here. And this features.py file is what's defining this entity called zip code, a data source called zip code source, feature view, and then also entity data source and feature view for credit. So you can see those are 6 things that are being, entities that are being registered, feature views that are being registered, and then infrastructure is being deployed. What infrastructure do we need? Well, for each of these feature views, we're going to deploy we're going to construct some infrastructure for you on DynamoDB, because you're probably going to need that when you do real-time inference and you want to get your online features. So the feature store has now been set up, and finally we use this command to materialize from the offline store into the online store. So you can see we're materializing our 2 feature views, one for our zip code features and one for our credit history, from Redshift into DynamoDB. So we're going to let this run in the meantime. Okay. That's a little strange. It seems like it is having some issues. Let's try it again. Okay, what exactly is the issue here? Query failed to finish. S3 service, S3 bucket addressed by the query is in a different region from this cluster. I think this S3 bucket might be wrong. Let me just try this real quick, and hopefully this solves the problem. I think this bucket should be in the same region. Great, okay. So I basically used the wrong bucket for staging, and the staging location, to be honest, isn't that important, but it is used when materializing data, so it looks like it was in the wrong region, so I switched to bucket in the correct region, and the feature views are now being materialized from the offline store into the online store. So that looks good. And the final thing to do here is to just train and test the model, and hopefully this should work. Once these feature views have been materialized, we're going to just train the model, run inference on it, and then we're going to talk about exactly what happened. All right. One of two feature views has been materialized. Let's see if there's anything else we can take a look at here in the meantime. So if we look at this run file, we're gonna see these loans. So maybe let's just take a look at what these loans might look like first. You know, let's just try running that. Oh man. That should have been in the requirements. Did not install. Okay, I guess we didn't properly install all the requirements. We'll just go ahead and do that. Let's try running again. Okay, great. So in here, let's kill this. In here we can see that the columns are these over here, and they match up with the columns that we have here. And basically, that makes sense. This loan request is just one row that we probably pulled from this loan data that we have. So basically, you have a bunch of data in here. You can see these are some of the rows in the database. And what you want to do when you train your model, so you can see we're going to call train on loans. And you can see in credit scoring model, if we call train, we need to get the training features based on our loans. And what's going on here is we're calling feast.getHistoricalFeatures, and we're passing in these loans as an entity data frame. And we're specifying that we want to pull a bunch of other features. And so what are these features that we want to pull? We want to pull these features. For zip code features, we want to pull all of these: city, state, location type, etc. For credit history, we want to pull all of these. So where are we getting these features from? Well, this is exactly where this data comes into use. So this is a data that we wrote into Redshift. It's basically our historical feature data. And you can see here we have one table for credit history, which has precisely all of the features that we want here: a credit card, a mortgage, a student loan, a vehicle loan, etc. And then the question, of course, is how do we know which row to pull in? And the answer there is for each one of these rows that is passed in this entity data frame, you can see we actually have a date of birth, social security number, and we actually have a zip code. So why is that useful? That's useful because that is going to be used to key into, basically as a join key on these rows over here. So if this is the date of birth, social security number, then we are going to look for the row in here which has the same date of birth, social security number, and join that to this data to be used for training. That's exactly what's going to happen when we call python.run. So why don't we try that? And since I've run this a couple of times, I know that it can be a little bit slow if we use all of the training data, so I'm just going to restrict us to only 100 rows basically. So it should be a lot faster to run inference. Loan rejected. Cool. So it looks like our model was able to successfully train itself and run inference. But of course, that's not really just what we're looking for. We're also looking to understand how Feast might have helped with this. So, maybe to inspect this a little bit more closely, why don't we try to do something like the following? Why don't we take a look at our columns here, and then take a look at columns here. And now, of course, we know that these columns are going to be the columns that we printed there. But we can take a closer look here at what happens after we join a bunch of information to it. Oh, okay, I think I know what's happening. So we already trained it, so the model has kind of saved the model weights that were left, and so we're actually not going to be able to train this unless we delete the saved model. And why don't we, while we're at it, also take a look at what's going on here. So we have this request coming in, and why don't we also take a look at the data that we're getting back, right? So we can take a look at this request, and we can take a look at the feature rec that we're getting. So let's run this thing again. So this will train again, and it will also run inference. Okay, so this makes sense. What's being printed here, of course, is the first instance. Oh man, I can't tell if I save that model correctly or not, or save that file. So let's just run it again. Right, so this is what's being printed here. These are our columns from our loans. And then, as I mentioned, what's going to happen is basically we're going to enrich this loans data frame with a bunch of additional featured data. And you can see here that exactly it is being enriched with a whole bunch of features about the zip code and also about the credit history. So that's how Feast can help you, right? You can take some entity data frame, which has some initial training data, and then you can basically add a whole bunch of data, a whole bunch of other data, feature data onto it. When it comes to inference, you can see that, excuse me, our initial request is here, and then after using Feast, we retrieved a whole bunch of online features, which, right, so the zip code, these are all some credit history things, and then state, etc. are the zip code features. And of course, since the model was trained with all of these features, we need to retrieve those features when we're doing online inferences. And that's exactly what Feast is doing here with this get online features path. And yeah, I think that basically concludes the tutorial. It's relatively straightforward, I think, pretty simple stuff. And I would encourage you definitely to look more into the documentation of Feast to get to dive deeper and get a sense of how you might continue using Feast. There's also this interactive demo, which I don't think is, really necessary right now to take a look at. And yeah, that's basically everything I had for this tutorial.
Felix, thanks for doing this, man. And we'll catch you on the flip side. I appreciate the demo. I appreciate all that.